Stoichiometry is the study of the relationship of reactants in products. Chemistry has three domains: macroscopic, microscopic, and symbolic. Stoichiometry uses symbolic chemistry to manipulate the amount of reactants to produce a specific amount of product, or vice versa. To understand this concept, we must first know the law of conservation of mass. Einstein's special relativity equated energy is equal to mass, and the first law of thermodynamics states that energy can neither be created nor destroyed, just transformed from one form to another. And so, this also applies to matter. Conservation of mass is the whole point of stoichiometry, and the mole allows us to exploit this observation. Mole is derived from Avogadro's law, where at constant pressure and temperature, gases contain the same amount of molecules, wherein 1 mole is equal to 6.022 times 10 to the 23rd power. Atomic mass is the sum of an atom's nucleons, namely protons and neutrons, given that electrons' mass is negligible. Atomic mass is proportional to the atomic weight, represented by grams. Atomic mass unit is the average weight of a specific element's naturally occurring isotopes. Isotopes are just atoms with different amounts of neutrons. Now we know how atoms are weighed. But how do they exist? Atoms or elements exist as either compounds, free states, or ions, which we will disregard for now. Compounds like this hydrocarbon named methane are two different elements binded to each other, and oxygen, which occurs as a diatomic molecule, is in its free state, since being diatomic gets rid of its charge. And helium is a noble gas that exists as a monoatomic atom, since it is stable enough to be on its own. There is one more important law in stoichiometry, that is the Proust law, or the law of definite proportions, which is basically saying that an atom combines with another in discrete proportions. For example, a carbon atom combines with two atoms of oxygen in order to form carbon dioxide. Stoichiometric factors. Stoichiometric factors are the result of Proust's law and allows us to calculate certain measurements of an element relative to another, using atomic weight and moles. So let's try it out. We're going to solve this problem. I have 1 gram of carbon. How many diatomic oxygen will it take in order to consume all this 1 gram of carbon? So we're going to calculate that using stoichiometric factors. So I have the equations here. Okay. So 1 gram divided by its molar mass. So this is going to cancel out using dimensional analysis. Okay. So we will have 0.083 mole of carbon, and then we multiply that by the molar mass of the atomic oxygen. So this will cancel out, mole. So it will take 2.656 grams of oxygen, the atomic oxygen, in order to consume all the 1 gram, making it carbon dioxide. So how many grams of carbon dioxide is the yield? How many is the yield? So we will just multiply that, add the grams. So we will have 2.656 plus 1 gram is equal to 3.656 grams of carbon dioxide. So check that. We're gonna make these grams into moles. So we were back in 0.83 mole. This will cancel out grams, moles, and then we will have 2.65. So checks out. Then we'll do it carbon way, 0.083 mole multiplied by the molar mass of carbon. So this just 0. Please cancel out. This is 0.996 or 1 gram of carbon.